Hello, my name is Homer Quintana and I'm the Program Manager for the Houston Methodist Center for Rapid Device Translation. Today we're in the Methodist Institute for Technology, Innovation and Education facilities, joined by Tobias Wilken and Philippe Onhager of AOT, a medical device company out of Switzerland. Gentlemen, it's a pleasure to have you here.
Homer, thank you very much for this kind introduction. My name is Tobias Wilken. I'm the CPO of AOT, Advanced Osteotome Tools, and we are a Switzerland-based startup developing a laser robot for medical application. We're here in Houston to do a usability trial, which is mandated to bring our device to the US market eventually. And yes, we enjoy being here and enjoy the opportunity to present our technology.
Fantastic. So tell me about your technology in general and its use.
Our mission is to digitize the OR. Imagine all those science fiction movies that you know, with a sick bay where a robot treats the patient with a laser. So we are bringing this technology from the movie theater into the operating theater. That's our mission. It all started when one of our founders, Alfredo Bruno, had his daughter to be operated on the jaw. And he went to Professor Seilhofer, surgeon at the University of Basel, maxillofacial surgeon, to perform this operation. And they actually had a quite interesting discussion, Alfredo being a laser physicist and Professor Seilhofer, a very innovative surgeon. Out of this discussion, they came up with the idea, hey, why actually not trying to cut bone with laser light? And out of that, they founded a company. That's AOT. That was 10 years ago. And by now, we put a lot of R&D effort, research, development, but especially also regulatory effort into developing a product. And here we are. After 10 years, we have our product on the European market. We have market clearance after a clinical trial and many other burdens. But by now, first system has been sold to a clinic in Munich, where one of our other founders, Dr. Jürgens, can now use it every day to treat his patients with a laser instead of a mechanical drill or saw. CARLO, that's the product name. It stands for Cold Ablation Robot-Guided Laser Osteotome, and it's in the name what it does. So we intend to replace mechanical instruments to cut bone with light. We're the first robot actually to do so worldwide at the moment, and it is even autonomously working. After this great milestone of bringing it to the market in Europe, that's just the beginning of our journey, however. During that journey that we had until now, we actually realized it's not only about cutting bone. We have much more potential with our device. We think it is the perfect, if not the only tool to really digitize the OR, to bring a pre-planned osteotomy, or actually pre-planned surgery, live into surgery. And why is that? We believe that robotics can only be done contact-free. Imagine a mechanical tool being inside the patient and the patient moves. You have a serious risk there. The mechanics, they are rigid, they are intolerant to a movement, and they have the danger to potentially harm the patient there. With our technology, with the laser, we are contact-free. Right? We just shoot at the bone, ablate it, but should there be any movement, we can switch off the laser immediately. And more, we can ablate at angles that are impossible to do with a mechanical tool. A mechanical tool will bend or skive. It is sensitive to density variations in the bone. So there's an intrinsic inaccuracy. With a laser, it just always shoots in a straight line, and we are insensitive to all those problems. So truly, we think with our technology, that's not just cutting bone, that's really about taking a pre-planned operation into surgery without loss of accuracy, and really shifting from the mechanical skills of the surgeon to his pre-planning of the surgery.
That's outstanding. What would you say are some of the benefits that surgeons can achieve while using CARLO?
That's a fantastic question. We have cold ablation with our laser. That means that we leave the cut surface actually cold. It is not thermally affected. And it can lead to faster healing. We have preclinical data in animal trials that supports our claim that out of a cut, the tissue is left thermally unaffected and starts healing quicker. And this can lead to faster patient recovery in the end. We can also do novel cut geometries, which are absolutely impossible with today's mechanical tools, since the laser on the robot can, of course, cut around corners and do fine lines that you wouldn't be able to do with a mechanical instrument. And that can lead, for example, to interlocking features. So you can imagine puzzle shapes, jigsaw puzzles, dovetail geometries, and the like. And they can even be load-bearing passively. So you just click, for example, the cut bone and an implant together, and they intrinsically are stable. You don't maybe need as rigid as a fixation as you do today. That's for the future. We need to show that clinically, of course. But that is something where we see in the lab, it just works perfectly, and we want to translate that into the OR. As a summary, our goal is to accelerate patient recovery, to reduce the complications in challenging situations, to speed up the operations potentially, and to assist surgeons in complex osteotomy cases with a safe device they can trust.
That's fantastic. Well, I'd love to see the device in action if you don't mind giving us a demonstration.
Absolutely. So here you see CARLO. The core component is our laser head. That's where all our lasers are built inside, and it's more than one. It's actually the ablation laser, which creates the cut. There's a visualization laser inside, which shows where it will ablate, because the actual ablation laser is in infrared, so it's not visible. And there is a third laser built inside, which will analyze the depth and visualize it later. The laser is actually mounted on a robot arm, which will guide the laser off the tissue, and it will do so repetitively because we shoot pulse by pulse. And therefore we need to repeat this motion over and over again until we have cut through. The system is controlled actually by a navigation system, regular surgical navigation. So this camera will observe the surgical field. It will observe where the laser head is, and at the same time also where the patient is. The patient marker needs to be attached to the bone that needs to be cut, and the camera will observe at the same time and tell the control software where to move the laser. The software is actually one of our largest efforts. So we have quite a number of software engineers designing the control software on the one hand, but on the other hand, an essential part of our product is also the planning software. So the surgeon in his office can pre-plan the operation, and it will be transferred intraoperatively onto CARLO, and he will execute the cut as the surgeon has planned it. So how do we cut the bone actually? We apply pulse by pulse, and this ablation is called cold ablation. It's called cold ablation because we actually leave the tissue thermally unaffected by our mechanism of action. We will predominantly heat up the water inside the bone because the wavelength of the laser is designed to do just that. And the water inside the bone will expand, evaporate, and create a tiny micro-explosion at the spot where the laser is focused, and it will rip the tissue apart in which the water is embedded, which is the bone. So the bone itself will not be ablated, but rather mechanically be ripped apart, and therefore the walls of the cut stay relatively cold. They stay colder than with traditional mechanical instruments. We have preclinical data on that showing that with a saw or with a piezo or with a drill, you will heat up the tissue even more than with our laser. At the end, we have a cooling spray that will then neutralize the energy which is in the water vapor that comes out of our ablation spot, and we will have a nice hole generated. So then we need to cut several holes, of course, next to each other with a robot arm to create the osteotomy line that was pre-planned. So now I would like to show you how to do that, and for that we first need to visualize the cut, how it will be done before actually executing it. So before actually cutting, we have to visualize the path, which means that we switch on our green visualization laser, and it will show the surgeon where the cut will be executed, and the surgeon can see if he can retract all the soft tissue, if there are no collisions, and if he is ready to execute the cut. Should he not be, he could modify the path quickly, but let's say this path is now just fine. So we can move into ablation mode, and I need to put on laser goggles for eye protection, and then we are ready to cut. Okay, then let's please stop the ablation process. And I have a handheld with a trigger, so as a surgeon I have the ultimate control over the cut at all times. So as soon as the laser is ready, I see it with the blue LEDs and I can start the ablation. So you see how the cut is generated pulse by pulse and segment by segment. We will not cut everything at once, but the surgeon has to see whether he has cut through the segment that he wants to cut. Then he can tell the operator, please move on to the next segment, and we cut the next segment. Now, as I mentioned, the patient could move. This is something where we are really tolerant against. So if the patient moves, CARLO will just follow. He will find the trajectory again and continue shooting where he was stopping before. Another safety feature that we have is that the robot is actually tactile. So it is sensitive to the touch. Whenever the surgeon or anyone touches the robot during ablation, he will automatically stop the cut. He will notify the operator that there has been a collision, that we shall check what's been going on. The operator can confirm that, tell the surgeon everything's good again, and start the ablation process again just where we left off. Another intrinsic safety feature is that our laser beam is strongly focused. And that means we just have ablation power at the point where the laser hits the bone. For example, if I put my hand at the top, I can just put my hand, it doesn't hurt, it doesn't damage my hand, because it simply does not have enough energy density at that location to cut my skin. If I would put my hand at the point where the bone is, it would of course start bleeding and hurting. So let's now continue with this osteotomy to finish it, and let's see what we can create. And we can have a look at the osteotomy we just completed. So we completed a nice jigsaw puzzle geometry, and actually what I have prepared is a fitting counterpart. I did that before. That shall simulate the implant, and I have the cut that I just completed. Now the obvious application is to just put it into place so that it fits. And now we have a really stable osteotomy, passively stable, without any plating. In reality, of course, you would put plating, but our idea is that potentially in the future you can reduce the stability of the plating because your cut intrinsically carries the load. And this implant actually can either be an artificial implant, pre-planned, pre-printed, and just inserted. It can be also coming from a bone bank, so that you prepare it pre-operatively as well, potentially with CARLO. And it can be an autograft, so you can take it out of the fibula, for example, or the iliac crest, and you can prepare it either ex vivo on the table or even in vivo with CARLO during the surgery.
Thank you for that very impressive display of your technology. It appears that you've got a platform technology with potential towards other surgical indications. So, what's next for AOT?
That's exactly right. CARLO is not just designed for one indication. It's a platform that shall cover a lot of indications in the future. At the moment we started with the oral and maxillofacial surgery space, but that's just the beginning. CARLO intrinsically is a multi-indication device. We can cut bone with light not only in one bone, but head to toe, basically everything. And we can not only cut a line, we can cut holes, we can ablate surfaces, and we can transfer the pre-planned accuracy and high precision into the OR. So we need to develop our technology further in order to cut faster to enable different indications. We want to improve the control, higher criticality, like for example neuro spine surgery. We want to broaden our intended use to also cut soft tissue eventually, or even do diagnostics. And last not least, we are actually, as I said, a software company. So we are looking for partners to develop software together with us. We couldn't cover all that on our own. Our idea is to build up a community of interested partners, universities and companies who will program software for the use of CARLO, for pre-planning and also for intraoperative application. So all in all, we like to compare CARLO with the iPhone. It's impressive technology, it shall be easy to use, but it has a vast potential for a community to provide apps for every imaginable use case.
That's outstanding. I've got a few more questions I'd love to ask you just about your general experience with your work here. So what brought you to Houston Methodist all the way from Switzerland?
Fantastic question. Yes, we originally had contact with Dr. Gattino, who's the chair of the oral and maxillofacial department here. So our founders and Dr. Gattino knew each other from conferences, so we knew, hey, there's great technology being developed. It's not only the surgery, it's really development and research that's done here. And we thought that might be a cool place also to come and do our usability evaluation.
So how did you connect with us?
So actually that was established by one of our investors, SHS, and they are in relationship also with the Mighty Institute or Houston Methodist in general. And via that we connected with you and could set up our usability study here.
Oh, that's phenomenal. I remember the discussion with the capital partner that you mentioned and really showcasing the facilities and expertise that we have here within Houston Methodist. So based on that, tell me about your experience with Houston Methodist and your general impression of the Texas Medical Center.
Actually, it's awesome. So I mean, we were received here very friendly. We got great support during the time that we're here. Very friendly people, but also outstanding technology. I mean, the Mighty Center that you have here, that is quite something. We haven't seen that anywhere else. So we love to be here and we feel greatly supported. And actually also being here at the TMC, it's a huge complex. I mean, we're overwhelmed by the size of it, but it provides us with an opportunity to have a lot of surgeons and medical professionals from different specialties with whom we can discuss, which can give input, and at the same time who can also participate in our study.
That's outstanding. So for the medical companies and startups watching this segment, what would be some words of advice that you'd like to share about your medical device development journey?
So actually the advice I would give is, don't focus only on your technology. It's your backbone. It needs to be solid, that's clear. But also take good care of the regulatory burden that you have to overcome when developing a medical device, and take care about your commercial strategy. Be ready for setbacks. Have a backup plan ready. So things might definitely take longer if you don't expect it, and it will be more expensive, so be ready for that. Regulatory burden is very high. If you don't know perfectly what you do, potentially you need to repeat things, and don't be afraid of using consultants. That's definitely a good recommendation, I think, especially for the FDA. Use a process. It can de-risk your regulatory approach and your go-to-market strategy. They will provide ideas, or they will give you an idea which studies you have to execute and which evidence is at the end required to bring your product to the market. Finally, consider your reimbursement strategy early on. It can help convince your investors to finance you, and it can be a lengthy process. So start it early. That would be my advice.
That's tremendous advice, and I agree wholeheartedly. Consult your regulatory bodies, consult groups that are going to help you get through these hurdles, figure out exactly what you need to do and do it well. So the last question that I'd love to ask you is, you've had some time to hopefully explore Houston, Texas. Tell me about some of the more memorable experiences that you've had here.
So actually, we did not have that much time. It was quite stressful, but yes, we had a few hours that we could spend, and obviously we went to NASA Space Center. It's fantastic. I mean, it's a great place, and especially if you're a technology guy like me. And the other thing, hey, Houston is a great place to eat and drink. So we had quite a few nice evenings with fantastic food and some local beer.
Oh, that's great to hear about our cuisine and our culture, and obviously NASA is a great legacy to Houston. I want to thank you and your colleague Philippe for your time in talking to us about AOT and its technology, and I hope to see you back in Houston in the very near future. This video was brought to you by the Houston Methodist Center for Rapid Device Translation. For more information, please visit www.rapiddevice-translation.org.